There's a related statement that sometimes we want to make in quantum mechanics, which is that of expectation values. Sometimes we don't want to know just the probability distribution of where the particle will be, but rather the average position it will be. So if psi norm squared represents the probability of being at one location, then how do I compute an average Well, what I do is I say an average coordinate, for example, is going to equal the integral of that quantity that I'm trying to average, let's say the coordinate, times dp dx, or x norm psi squared dx. This is a lot like saying if I wanted to calculate the average class score on an exam, I would do a sum over all possible class scores, 0 to 100%, take a particular class score, and I would multiply by the number of students with that score. So that would be like the probability density. And the integral up above here is kind of like a limit of this. This represents something like x, and this represents something like p of x. And all I'm doing is taking the limit where the sum goes to an integral. So in that sense, my calculation of an average or an expectation value is no different than something we're used to in ordinary statistics. So here's a question for us all to consider. What's the average position of a particle in a box when it's in the first excited state, whatever it's n equals 2. That's again something I'll calculate for you in a separate tutorial, but I encourage you to try it for yourself right now.